how is a company from Estonia solving mobility in more than 150 cities? Today I'm going to share how data and data science contributes to the solution. What Bolt is about? It's about reducing the time and money we waste in transportation and reducing the waste we create on the planet altogether. One part of the solution is ride-hailing. It's about increasing the utilization of the cars, sharing the cars, not having them stand idly in parking lots. What the ride-hailing does, it connects the rider with the driver in a way that the rider gets the service they need reliably to get from point A to B to C to D, and gives the driver better earnings on our platform than with other players in the market. So Bolt is not just ride-hailing. Last year, our product managers extended our platform to allow also food delivery, such that you can enjoy food at home with your friends with a warm food. And it was quite straightforward to extend the platform. You just add a third party to the system, a restaurant that provides the food. So this is part of solving the mobility needs of future cities. But of course, solution is not just in cars and motorcycles, it's also in the scooters that we're talking about today. And the electric scooters are excellent way for moving small distances in great weather. But if you have more people, you will want other types of vehicles. So this is why we started the self-driving lab with Tartu University, and on Tuesday some of you might have heard about that. I will share with you why we think self-driving is an important piece of the solution next to scooters, ride-hailing, food delivery, and many other transportation services we need in the cities. Bolt has grown quite a bit over the years. By now we have 30 million riders, and we operate the company with just a bit more than 1,400 people in more than 35 countries. It's a team effort. Data scientists, data engineers, they contribute to the solution, but many, many different functions are needed to operate such a business at scale. So my goal today is to share with you what it takes to build a data team or a data-driven business, and how to use data in your business. But just to give you a sense for the scale of Bolt, let's look at how much data do we have. Last year, we reached a petabyte scale. And here you can see a histogram. On x-axis, you can see how much data there is, and on y-axis, you can see the number of data scientists who work with that amount of data. So it's considerable in size. But of course, if you compare Bolt to the entire planet's data, then there is more than 33 million petabytes worldwide. But the difference is that companies focus on high-value data. So if you plan to work with your company and find value in data, do focus on high-value content first. Having successful data team in your organization is actually dependent on many different disciplines. One of those is, of course, software engineering, because eventually it's code running on computers. The other is applied research, because data science is less mature field than software engineering. There are much more complex requirements for getting results in production, and I will show you why. But of course, essential piece in this is business. What you will see when you use machine learning or data in general, you will see single-digit or double-digit improvements in your business or operations. which means that you better focus on areas of high volume, high impact, because otherwise you waste the valuable resources and brains you have. The process itself of doing data science, it's quite similar to any company in the world. First, you collect the data from the real world, you process and clean it, you look for patterns in the data, and once you find the valuable patterns, you take those patterns and you put it into production. And what it leads to is that as you have more data, your product gets better thanks to using more of the insight in the data. And as you get a better product, you get more users, and the cycle continues. So there is a virtuous cycle in data science. The field itself is, of course, not new. There is the part of business intelligence and creating insight to make decisions. I will focus on the automated part. How do machines make decisions for us when you have many users, many cities, many business cases? You need quite a lot of infrastructure to do it successfully. When you enter data science, you probably have an expectation. We are going to do a lot of cool math, a lot of model optimization. But then reality hits you. It's quite different. You spend most of the time cleaning the data, finding it, integrating your solution with the rest of the system, making it useful for the users, and developing the infrastructure. And this is not unique to a single company. So Googlers did an informal survey, and they found this to be true for many companies. So what it leads to is that the reality, compared to the expectation, means that the projects take actually much longer. And the core piece of data science, defining the key performance indicators, KPIs, and then optimizing the models, it's just a small fraction of the entire project duration. So how do you work with data at scale efficiently, such that your projects don't take long and you react fast and move in the right direction? So to give you the context, here is comparison of machine learning code in relation to all the other code you need in production to get value out of data. As you can see, machine learning is just a small piece of it. You need to collect the data, serve the endpoints, monitor it, verify the data. You need many different systems to get value from it. And that's why you should look for ways to automate rest of the activities around AI and machine learning. At Bolt, we created a data platform for this. And the data platform is a straightforward piece of engineering built on top of existing technologies. It's a data lake. It's a data storage where you keep the data so that you can access the data easily with very low latencies and also index it. Once you have the data in the storage, you need to transform it such that the machine understands it. And this is what pre-processing does. And once you have many business cases, hundreds of cities, millions of users, you will also need to automate how you maintain the models in live. How do you deploy them? How do you scale them? How do you make them secure? So whatever happens stays contained. All this is built on data quality. What does it mean? It means that if you put garbage in the machine, you will get garbage out. So you better work with good signal. You must test the data, you must check the quality of the data, you must ensure that whatever goes in decision-making is of high quality. So part of it is can be automated, but part of it is done by people. So they need to look into the data and find new value in it, new insight on whether something needs to be changed. And since Bolt doesn't have thousands of engineers compared to other players in the market, we build as much as possible on what exists, because as you saw in the previous slide, it takes quite a bit of engineering to operate at scale. And where it leads to, the projects take less time. You can create more ideas, deliver it to the market faster. Of course, that's even too long for us. We want to make it even shorter. How do we make it shorter? How do we deliver things faster to the market such that our riders and drivers benefit from it and we grow faster? Well, we created a simulation engine for this. And what it does, it has a city map, and on top of it, we put in our understanding of how people behave to different prices and ETAs, how they use our service, and then we compute what will happen if we release a new algorithm to our users. Real life just takes too long. Sometimes you have to learn faster. So that's how we do it. And we have written about it at Bolt Labs blog post quite a bit if you want to learn. So, to summarize the data part, where do we use the data at the company, and where do we use machine learning? By now, we use data basically in every decision we do in the company. The automation focuses on the highest value business cases first, because as I explained before, you want to get the improvements in areas of high volume, which means in our case that we compute the prices that you see such that the rider will accept it and also the driver will accept it. We also use it for maps, for estimating the ETAs. And I know you experienced poor ETAs at some point, so that's part of the challenge of solving something at scale. It's getting better over time. Then the money we make with commission, we still want to reinvest into growth. Bolt is about high growth. For this, we need to decide in which cities do we spend our budget, to which users do we give the discounts, to which drivers do we give the bonuses, and when. So all these areas utilize machine learning, operations research, and many other mathematical and algorithmic solutions. Of course, it's not just about scaling what you have. You have to think what's going to happen tomorrow to be ready. And for us in the transportation industry, we think a vital piece of the solution is self-driving. Why is it? If you compare the price of all the different forms of transportation for our users, it's evident that having a driver for all rides is not going to scale. If all of us would use ride-hailing for all the rides we do, every seventh person would need to be a driver, and that's not going to happen. So you need scooters, you need self-driving to fulfill the increasing mobility needs we have. Of course, if you look at the ride price today, well, the technology costs that much that you cannot bring the service yet on the market, especially in developed countries and developing countries. So the project we started together with Tartu University is about understanding what it takes to mature the technology enough to get the right price to be reasonable for our end users. What does it mean? So if you look at the levels of autonomy or self-driving, then here is a standard way of looking at it. All of you have seen or experienced Teslas, heard about Waymo doing pilots in Phoenix even without a driver, but no company has reached yet a state where they don't need a driver at scale. Level 4 is where the economic viability will start. And it's solving self-driving takes quite a bit of data and experiments. So that's why we set up a lab, a real car with sensors on it, such that we can test the different driving scenarios. What it has is a 32-beam LiDAR, which collects a point cloud using lasers, such that it can see what's going on around it, as well as 6 cameras for 360-degree view. There is also a debate, okay, do you need a LiDAR at all? The lab has both directions it will explore to understand which one performs better. The way Bolt does decisions is very data-driven, so we look at different solutions and then compare and select the one which performs better. So what's cool about self-driving in Estonia is that we have poor weather. We have snow. We have rain. The traffic conditions are different from what you have in the valley. So to operate the car in poor weather, you also need a radar, also when moving at very high speeds. Using this, you can perceive the world around the car, but you also need to know the position of the car, for which we use positioning device that combines data from GPS, US, Europe, Russian, Chinese satellite constellations, and then gives you a 5-centimeter precision of the location. The inertial measurement unit tells you how the car is orientated in space. You can think of it as mobile phone, gyroscope. And one piece that's necessary at the moment is high-definition maps. What is it? It's about collecting the information about the lanes and streets at very high precision, and then making it available for comparing it to the positioning information you get from the car measurements. And as you will see, it makes quite a bit of things easier. So software and maps are the areas we focus on, because we think these are the main challenges for scaling self-driving in all the cities we operate in. And then, of course, there are some computers on board for controlling the car. Now, you sit in such a car. It looks like a normal car with just a few screens. But for the computers on board, it looks different. It will recognize the vehicles on the road. It will recognize the pedestrians. It will know in which lane it is and in which lane it can move to. It will recognize the traffic signs, which are very location-specific. Getting a car driving in US is different from getting it driving in China or Europe. So once you have all the information from the sensors, you compare it to the maps you have, and what you can do with it is to understand which objects are likely to move and which are not. So on high level, how self-driving works is it does sensor fusion for all the input sensors, and then combines it with maps information, does the planning decisions, and then gives control commands to the car to steer it, to accelerate and brake, depending on the traffic situation. So you see, what looks like a simple app to the end user involves quite a bit of engineering, solving what's there now and also thinking about the future, such that we can solve our urban mobility needs with scooters, with ride-hailing, with self-driving, and make the people's lives and the planet better as we scale the company business-wise. Thank you.
Thank you, Andre. Very interesting talk about a company that I think we all have some use for. You made a mention that you're in the self-driving, and you had a line that was like, it's very different to get a car on this road in the United States than it is in Europe or China. What did you mean by that? laws or something else?
Regulations, of course,
Okay.
but also the traffic. So self-driving depends highly on weather. It depends on the density of traffic. It depends on how narrow or wide the streets are. So it depends on the traffic signs, how you have them designed. They are not uniform in all the different countries. So, and of course the regulations and people's readiness to accept self-driving is also an important factor. If you remember, elevators used to have also people driving the elevators once they came on the market. So for a while you need self-driving safety drivers until people accept those.
Okay. So very broadly speaking, where are the regulations better for you? The United States or Europe or China?
I think we are going to see self-driving first on the highways. It's already solved in some countries, right? And in US, in California, you see quite many cars, people taking naps in the cars without recognizing that actually it's not level 4.
Because on the other hand, I go, China, everything must be available there. Sure, do whatever you want.
Oh. China is different, yeah.
Okay. All right, so then that's it. Okay, at a legislative level, maybe America's a little bit ahead or something like that. But then you were sort of talking about weather and the road styles, highways versus smaller roads then. Does that also favor the United States because they love their big roads and large cars, where in Europe we want small cars and small roads?
I think there are use cases for different vehicles. So Taltech has a bus. We have a car with Tartu University. The vehicle you use depends on the number of people you have, and you need to get from point A to point B. So the engine we build, for example, the data platform, we build with quite a few years ahead, looking ahead into the future, such that the company can scale using the platform. So I think the same is true when it comes to any vehicle. So you have to choose the right car for the purpose.
Sure, makes sense. Okay, one final question, a little bit of a tangent to what you're talking about. How are Bolt and yourself, and I guess your work with the university, thinking about the ethical issues about self-driving cars, accidents, who's liable for this sort of stuff? Are these issues that cross your plate, or do you get to sort of just look at a more technological level and that's what the business has to worry about?
Yeah, as I told, Bolt is team effort.
Sure.
So we have people working with the governments, with the cities, with universities, to make sure that what technologies we bring on the market are safe. For Bolt, it's very important, the ethical part of making business, and AI, as any new technology, has risks related to it. We are very conscious about the impact automated decisions can have on people. I think when it comes to impact on people's lives, then the healthcare and finance industry have the highest impact on people's lives.
Okay, very good. Please, one more round of applause for Andre. Thank you, sir.